Indonesia's energy scene is moving really fast right now. Right after launching B50, a 50% palm oil biodiesel blend, the headlines shifted to two huge new players, thorium and hydrogen. At the leaders' briefing back on July 16, 2026, themed Energy Security and Mobility as Engines of National Economic Growth, Hashin Joyohadikusumo, the special envoy for energy and climate change, took center stage to talk about using thorium for nuclear power. Just a few days later, on July 21st, the Global Hydrogen Ecosystem Summit 2026 kicked off to dive into hydrogen energy. Energy Minister Bahlil Lahadalia was in attendance, and notably, PLN CEO showed up for both events. So, what actually are thorium and hydrogen, and what do they mean for Indonesia's power grid? Do we have to choose between them, or can they team up in our energy mix to lock down Indonesia's energy security? Let's start with thorium. Now, the name sounds pretty exotic, right? Probably because people group it together with uranium and plutonium, the heavy-hitting radioactive stuff used in atomic bombs. But in reality, thorium is a totally different story. Even though it is radioactive, it's way more stable, and its natural radiation levels are much lower, making it far safer for humans. Here's the catch. Thorium can't just start a nuclear fission reaction on its own. It needs to absorb a neutron first to transform into uranium-233. Only then can it kick off the chain reaction that generates massive amounts of heat and energy. Even with that extra step, thorium is wildly efficient, producing way more energy than standard uranium. Almost the entire mass of thorium gets used up to produce energy. Because of that, it leaves behind significantly less radioactive waste. In fact, a thorium reactor can pump out 40 to 50 times more energy per ton of mined material than a traditional uranium reactor. On top of that, thorium is much easier to find. Experts estimate there's 3 to 4 times more thorium in nature than uranium. Another huge plus, its radioactive waste decays much faster, taking about 300 to 500 years, compared to uranium waste, which can stick around for tens of thousands of years. And perhaps most importantly, thorium is extremely difficult and ridiculously expensive to weaponize into a nuke. That keeps regional geopolitics peaceful and avoids raising red flags with neighboring countries. With all these perks, it's no wonder people are calling it green nuclear. So, what about hydrogen? Well, hydrogen is actually the most abundant element in the entire universe. The catch, pure hydrogen gas, H2, is surprisingly rare here on Earth. Why? Because hydrogen loves to react and bind with other elements, forming compounds. On Earth, most of our hydrogen is trapped inside water. Good old H2O. Now, water is an extremely stable compound, which means it takes a whole lot of energy to break it apart into its base elements, hydrogen and oxygen. One classic way to do this is through a process called electrolysis. Luckily, when it comes to water, Indonesia hit the jackpot. Thanks to our high rainfall and being an archipelagic nation surrounded by oceans, water is everywhere. On top of that, geologists have actually discovered potential reserves of natural hydrogen right in the Earth's crust in central Sulawesi. So, how do we actually get our hands on these energy sources? Let's start with thorium. Thorium is typically a byproduct, an extra gift, if you will, that gets dug up when mining other minerals. In Indonesia, tin and bauxite mining have huge potential to produce thorium as a secondary yield. In fact, Indonesia is sitting on massive thorium reserves, estimated at 140,000 to 150,000 tons. Now, back to hydrogen. Even though we have water everywhere, extracting hydrogen through electrolysis takes a ton of energy. When you power that process with renewable energy, you get what's called green hydrogen. It's super clean because the only things left behind are pure hydrogen and oxygen. The second method uses fossil fuels like natural gas or coal paired with carbon capture technology. This gives us blue hydrogen. During this process, carbon dioxide is produced as a byproduct, But instead of releasing it into the atmosphere, it's captured and locked deep underground using carbon capture and storage, or CCS. That way, it doesn't pollute the air or contribute to global warming. Then there's gray hydrogen, which is basically blue hydrogen but without the CCS part, meaning all that CO2 goes straight into the atmosphere. So what about the waste when we actually use hydrogen for power? Practically zero. The only byproduct you get when hydrogen reacts with oxygen to produce energy is pure water. So the big question is, which one should we choose? Thorium nuclear or hydrogen? Well, the real question isn't which one to pick. Since Indonesia has plenty of both, why turn it into an either-or situation? In fact, it's the exact opposite. These two elements can actually team up as vital pillars of Indonesia's energy mix and national energy security. Thorium reactors can be used directly to generate electricity, making them a prime candidate to become our main baseload power provider. With its insane energy density, thorium is massively more efficient than coal or diesel and leaves behind a fraction of the waste. To put that in perspective, just 1 kilogram of thorium in a molten salt reactor, or MSR, can generate around 24,000 megawatt hours of thermal energy. That's equivalent to burning roughly 2,000 tons of coal, or almost 1 million liters of crude oil. On the flip side, hydrogen is already being produced right here in Indonesia by our state electricity company, PLN. And now, as part of the push toward net zero emissions, Pertamina is jumping in too, even exploring natural hydrogen trapped underground, often called white hydrogen. Originally, hydrogen in power plants was used as a cooling agent for steam and gas turbines. But today, renewable sources like solar and wind can produce hydrogen, which can then be converted back into electricity using fuel cell technology. Right now, PLN produces over 200 tons of hydrogen a year, but only needs about 75 tons for internal operations. So the Ministry of Energy and Mineral Resources, ESDM, is stepping in to put that surplus to work. They're looking into replacing petroleum with hydrogen in diesel power plants, and even collaborating on public transport initiatives, like testing hydrogen-powered Transjakarta buses. It all sounds great on paper, right? But are there any hidden roadblocks or drawbacks to adopting these two as primary energy sources? Short answer, yes, absolutely. When it comes to thorium, despite all the perks over uranium, the reactor technology just isn't as mature yet. There's still a lot of research needed to figure out the best design. The current go-to approach, molten salt reactors, has a major issue. The liquid salt medium is extremely corrosive, which degrades the reactor parts quickly and shortens its lifespan. That said, there are some exciting developments. As Hashim Jojoharikusuma pointed out, he was recently invited to inspect cutting-edge thorium tech from China and Denmark, including micro-reactors small enough to fit on the back of a truck. If that tech proves viable, it's a game-changer for Indonesia's remote islands and off-grid regions. A tiny reactor like that could crank out 2 to 4 megawatts, plenty of power for small communities. So, what about hydrogen? Since most hydrogen is locked up in water, and water is a super stable molecule, breaking it apart requires massive amounts of energy. Because of that, hydrogen from water isn't a primary energy source. Producing it right now is pretty expensive compared to other options. Of course, things could change if we discover massive deposits of natural white hydrogen, but the chances of that being enough on its own are quite slim. Still, hydrogen is a squeaky clean energy carrier that leaves zero waste. And as part of a diversified energy mix, especially with today's wild geopolitics and volatile oil prices, exploring alternatives like thorium and hydrogen isn't just a cool idea, it's essential for our energy security. What do you think? Let me know in the comments below, and don't forget to like and subscribe. Thanks for watching.